Welcome back. This is lesson 27.2. In this lesson, you'll learn about hash tables. Hash tables are an easy way of storing data in a table form for quick retrieval. In this lesson, you'll find out what the hash table data structure is, what hashing algorithms are, the problem of collisions, and the advantages and disadvantages of using a hash table. As you know, the basic structure of the computer's memory is the array. An array is a set of memory locations, each of which has a numerical address. If you know the address of an item, you can access it in a single operation. But if you don't know the location, then you have to traverse the entire array to find the value that you want. When you're using a hash table, the data value that you want to store is processed to produce an integer value. This number value is used as the address, so the data value is stored at that address. So if we processed a data value and the result was the number 100, we would store that data value in location 100 in our array. There are several advantages to this idea. The storage location is generated from the data value, by the way, using an algorithm that will always give us the same result. That means if you know the data value you're looking for, you know where it must be stored. That means you can get to the data in one operation. And that gives us a big O value of 1, which is the best possible data value for finding the data we want in the computer. So let's think of an example. Every student in a college will typically be identified by a unique ID code. Might be called student code or something like that. If we have a method by which we can turn that ID code into a number value, we can store the student record in that location, and then we can always find the student's record in one step. How would we do that? Well, for example, we might find the ASCII value of each letter in or character in the ID code, multiply it by the position of the value in the word, and then add all the values together. That's just an example. We'll do some examples in the next lesson where we'll write a program to do this. And that would be called a hashing algorithm. It's quick and easy to find the stored value. It takes a single operation, so the big O value is 1. So many modern systems use hash tables. For instance, if you're going to log in to a social media account, it will go directly to your, through your unique username, it will go directly to your account. There won't be a long search process. That wouldn't be possible because there are so many millions or even billions of people who have an account. Now, of course, there are disadvantages to using a hash table. It needs a lot of spare memory space. You need a lot more space than you have data values to store. A hash table won't work unless there's a lot of empty space in it. If you haven't got much empty space, you tend to end up with collisions. What does that mean? Well, it means that if two of the data values you want to store end up with the same hash value, then they're both trying to get into the same space. It's like if you had an overcrowded car park and two cars were trying to get into the same space. And the smaller the hash table, the more likely a collision like this is. if we do end up with this problem with two values trying to get into the same space, they don't crash into each other as in the picture. Instead, the computer will look for an empty space. The second value to arrive will be passed on to a new empty space, and this is called rehashing. And it doesn't make your program crash, but it does slow it right down because the computer has to look to find an empty space. And as your hash table gets full, this gets more and more likely. How does this relate to Python dictionaries? Well, remember that dictionaries are made out of key value pairs. The key in a Python dictionary is used as the hashing value, and the value is the data stored at that location. So hash tables are the way that Python implements the dictionary data type. So hash tables are areas of storage where values are stored in a location that is generated from the data value itself. Turning a data value into an integer is the work of a hash algorithm. If two values end up in the same space, that's called a collision. You need to do rehashing, and that slows the program down. The big benefit of a hash table is it's very quick. It's a very quick way to access the data you want. The limitation is you need to have plenty of storage space, or it starts to go wrong with collisions. So we're going to make a program in a few minutes in the next lesson. So here's an overview of what to do. Create an array, let's say with 100 empty strings in it. Input a value, turn the value into a number from 0 to 99 and store the value in the correct position in the array. So that's the idea, but in the next lesson I'll take you through this task in more detail. So bye for now.